Dr. Dean, please introduce yourself and tell us a little bit about what you do.
I'm a professor at the University of Mississippi for about 20 years, and my profession is on infrastructure and disaster mitigation. For many years, I was involved in roads, city streets, highways, and airport pavements to select proper maintenance rehabilitation interventions, so the life of the pavements can be good and there's not much stress on the pavement, and before it becomes unsafe, we are able to provide the right type of maintenance and rehabilitation. As you see on the pavement, there are cracks here, so we don't want these cracks to become too much problematic for the users, for driving public. Anyway, let me tell you about now the PEDD software, PEDD software for Windows, which has been in existence for over 25 years. It was developed as part of my PhD, used all over the world, in the United States, many states, many consulting firms, many state highway agencies, as well as in Canada, Brazil, Japan. Many countries have used this, people have used it. So with this background, now the Windows environment has changed. So we developed this new version, which still got the same analytical routines like it was 25 years ago, but now it is...
Can you explain a little bit about what it does?
So this software, which is now we have done on .NET, does exactly the same thing that we have been doing for the last 25 years, which is to find out the in situ, in place properties of different pavement layers. For that purpose, we use several types of dynamic deflection devices. Two of them which have been very popular is a falling wedge deflectometer, or FWD, as well as historically since 1960s we have Dynaflect, which is a very small device but essentially does the same job.
So what is the primary purpose for a layman's perspective? Why should I use the software?
So when this data is collected, we need to find out what is the in situ conditions of the pavement layers, and we do that by using some theory along with this data which we collect by these two devices. We call them non-destructive devices, and using this data and some essential output, we can find out the existing in-place material properties, engineering properties of different layers, which is used to come up with the proper rehabilitation and maintenance alternative. That was the purpose of software, is to find out the in situ material properties. We call them modulus. That properties, this software does that in a very unique way. So we get a very unique results every time we put the deflection measurements and pavement layer thickness. It provides us the modulus. These modulus are corrected for the non-linear behavior of subgrade soils, which is the road bed.
So is it applied only to new roads that have been recently made, or?
It is applied for all types of roads. There should be existing roads,
okay,
new or old.
So even this one with these cracks and this, they're not maintaining it properly.
Yeah, this is the time to apply the software, this equipment first. You have to collect the data.
So the equipment is measuring deflections
under a certain load.
Right.
These are dynamic load, that measure dynamic deflections, and the software is the one which analyzes the deflection data.
So why is this tool better than other tools?
This tool is better because it provides unique properties and which are more reliable, and also provides the non-linear properties under the truck load for materials like granular beds,
so especially highways,
for highways and airports, and city street like this street.
Okay.
So this software actually has got proven record of providing the most reliable in situ modulus values of pavement layers, which is the first input in proper maintenance and rehabilitation design.
So what does it tell you at the result? What is the result?
These are the results.
No. What is the result? You put in data, properties, the deflection. What is the result that your tool gives?
We put the layer thickness and the deflection measurements data. Then it provides us the in situ material modulus. If you put the traffic data, it also provides you remaining life of this pavement, and as well as the...
So it tells you approximately how long this pavement will last.
Yeah, there's remaining life, and then also it tells you for future traffic, if there's need for an overlay or for in-place inlaying, it will tell you all that as well.
Okay. And how is this software available right now?
The software is available through EMA, as a commercial product, and it is developed in .NET environment, so it's very fast, and it gives results which are very reliable.
And how did you begin this product? Is it based on some research that you did in your PhD, or is it based on some previous work?
As I mentioned to you before, you are reminding me about my PhD, so I've become very old by looking. But was done 25 years ago, part of my PhD. But then since 1993, it's been commercialized for several clients in Mexico, as well as in Canada and US.
Why do you need accurate results that this tool provides?
Because if you don't get the right material in situ properties, all your rehabilitation design for maintenance will be wrong as well.
So if you're wrong about the life of the pavement, then you have to spend more money later on.
Yeah, because the pavement, if you put less thickness of overlay, less structural design, strengthening,
You have to spend more money.
It's going to fail within a few years instead of 16-20 years.
Okay.
If you do over design, then it still is going to fail because environmental effect is always there.
Okay.
So
And you waste money.
And you waste money in both cases.
Right.
Because if you do under design, you have to, user cost become too much because as you see, they stop the traffic. If you design for over design, then you waste money too because you could invest that money in someplace else.
Okay.
Because you'll be always short of money.
Well, thank you for the interview. It sounds like a very good product.
Thank you.